Welcome, curious minds, to the Deep Dive. I am absolutely thrilled you've chosen to join us today because we have compiled this amazing stack of sources. And they don't just present scientific facts. No, they build this, ironclad case for science.
Yeah, as the most potent, really the most beautiful and profound source of poetic wonder there is.
Exactly.
So this is really a deep dive into awe, I suppose. Our mission today is to show you how real fact-based science fuels those aha moments. You know the ones.
Oh, yeah.
And they're just far more satisfying, far more profound than anything, superstition or misinformation could ever really offer.
Right. We're basically offering you a shortcut, a way to get truly well-informed about the sheer vastness of the universe and, crucially, your own impossibly lucky place within it.
And speaking of impossible luck.
Yes. We had to start with this. It's a highly provocative claim, but it's statistically solid. So brace yourself right now as you're listening. If you look at the sheer weight of universal time and space, you are overwhelmingly likely to be dead.
It's a stark thought, isn't it? A bit terrifying, maybe. But it forces us, I think, to really confront the extreme improbability of our own existence.
It really does.
This whole deep dive is about understanding that cosmic lottery we somehow won just by being here now in this moment.
That is the ultimate hook, I think. And look, before we really unpack the astronomical math behind that dizzying thought, we do need your help. We want to keep these in-depth explorations going.
Absolutely.
So if you appreciate us diving into the sources this deeply, could you just take a moment right now, smash that like button, maybe comment below with your favorite analogy. Today, we've got some good ones coming up.
We do.
And of course, please subscribe. Your support, honestly, it's what allows us to keep digging into this beautiful world of facts.
Okay, so where do we start with this improbability? Let's begin with the personal timeline. To really grasp the miracle of you specifically, we have to look at the singularity of conception. That moment, looking back, it was the single most decisive event in your personal fortunes. No question.
Right. And if we sort of set aside the theological questions for a moment, when a soul might enter the picture and just focus on the quantifiable bit.
The biology.
Yeah, the biology. That successful union of one specific sperm and one specific egg. Before that precise moment, the chances of your unique consciousness, the one listening right now, existing were, basically zero, right?
Effectively zero. And then afterwards, suddenly the odds become, as one source puts it, trillions of times more foreseeable, which is still, relative.
Trillions.
Yeah.
But even that foreseeability,
yeah,
it's not a guarantee, is it?
Not at all. The sources really hammer this home. The biological hurdles are just immense. We tend to forget, I think, that even after fertilization actually happens successfully, a huge number, a significant majority actually, of conceptuses end in really early spontaneous abortion, often before the mother even realizes she's pregnant.
Wow. So just navigating that first biological maze?
Yeah.
That's already a massive stroke of luck.
Profound biological luck. Exactly.
But the lottery, as you said, it starts way, way earlier than that moment of conception.
Oh, much earlier.
Right.
We have to trace this, endless chain of necessary events backwards. Your parents had to meet, obviously.
Right.
But then their parents had to meet, and theirs, stretching back through just countless generations.
It boggles the mind.
It requires this impossibly long, often incredibly fragile historical thread to remain unbroken.
Fragile is the word. You mentioned Desmond Morris, the zoologist. He had a great example of this from his own family history.
He did, yeah. It's a fantastic illustration.
Yeah.
He traced his own existence back to a very specific, rather dramatic event during the Napoleonic Wars, specifically the Peninsular War.
Okay, get this. His sources show that if it wasn't for one particular French cannonball,
A cannonball?
yeah, fired by Napoleon's forces, he might never have been born. Because that cannonball, it shot off his great-great-grandfather's arm, which forced him out of his planned military career, sent him down a completely different life path. And that path eventually led to the chain of events resulting in Desmond Morris.
It's a very dramatic example, of course, but the key takeaway, the sources emphasize, is simpler and maybe even more profound.
Which is?
That the thread of historical events holding up our existence, your existence, is, quote, wincingly tenuous. You don't need a cannonball. You don't need Napoleon.
Right, that's the real crux. It could be anything. Think about, some humble medieval peasant who happens to be a necessary link in your specific ancestral chain.
Okay.
All that peasant had to do was sneeze at a slightly different moment. Maybe they delay by half a second, turn left instead of right, And maybe they miss meeting their future spouse entirely, or they meet them later under different circumstances leading to a different child or no child.
And that infinitesimally small difference just ripples forward through history.
Completely altering the chain reaction, ensuring that one of your potential ancestors becomes someone else's instead. It's this endless, chaotic cascade of contingency, like butterfly wings flapping.
Okay, so let's loop back to that really disturbing statistic we started with. The overwhelming probability that you are dead. This is where deep time comes in, the moving present.
Right. The universe is just ridiculously old, older than 100 million centuries. And our sun, it's got a comparable amount of time left before it, swells up and swallows the Earth.
So the idea is our experience of existence right now is just this fleeting, subjective slice of time, like a tiny spotlight inching along a gigantic ruler measuring cosmic time.
And we just can't visualize that scale naturally. Our brains didn't evolve for that.
Exactly. So let's use the analogy the sources provide to try and ground this. Imagine that huge ruler of time represents the entire lifespan of Earth, from birth to eventual death.
Okay, got it. A very, very long ruler.
Extremely long. Now, the odds of your century, this tiny little sliver of time you happen to occupy, being the exact spot where the spotlight is shining right now, are apparently the same as the odds that a single penny, tossed down totally at random, will land precisely on one particular ant.
Just one specific ant.
Crawling somewhere along the entire road, stretching all the way from New York City to San Francisco.
Wow. Okay. That puts it in perspective.
Yeah.
You are the ant. Your century is the ant.
You exist in this impossibly rare sliver of the universe's total duration. Not just geographically rare, but temporally incredibly rare.
And if that wasn't enough to make your head spin,
there's more.
We have to talk about planetary improbability. We didn't just win the time lottery, we won the location lottery too.
Right. Our planet, Earth, it's described as all but perfect for our kind of life. Now, obviously, we know its faults, right? There are deserts, misery, earthquakes, volcanoes, natural dangers everywhere.
Sure, it's not literally perfect.
But compared to the vast, vast competition out there, the dead, freezing vacuum, the roasting, toxic atmospheres of other planets relative to that, this Earth really is paradise.
And the math on this is just staggering. Even if you're being really optimistic, the chances of any randomly picked planet being suitable for life like ours, it's less than 1 in a million.
Less than 1 in a million. So the sources offer this great thought experiment to help us feel that look. Imagine this huge spaceship full of deep frozen explorers. They're fleeing some catastrophe on their home world, maybe an unstoppable comet. They're on this centuries-long, incredibly forlorn mission to find a new home.
And they know the odds are terrible.
Terrible. Maybe 1 in 10 million worlds might be suitable. They're probably expecting failure.
Okay, so the ship flies on autopilot for ages.
Millions of years, maybe. And then, against all astronomical odds, the robot pilot does get unbelievably lucky. It finds one.
It finds the paradise planet.
Exactly. The survivors wake up from their long sleep, they stumble out into the light, and they just can't believe it. This lush, perfect world, oxygen, liquid water, energy from a stable star, everything they needed.
That's a cool story.
But here's the reveal. That incredible multi-million-year journey, defying odds that are basically astronomical. That's our reality.
Right. We didn't arrive on a spaceship.
No, we arrived through birth. We gradually became aware of this world through babyhood, childhood. But the core point is the fact that we slowly apprehend our world rather than discovering it suddenly like Rip Van Winkle waking up.
That shouldn't take away from the sheer wonder of it.
It shouldn't subtract from the wonder at all.
And this brings us back to that really crucial point, that philosophical edge we touched on earlier. We are just profoundly lucky, not just to live here, but, as the sources put it, to be granted the opportunity to understand why our eyes are open and why they see what they do.
In the short time before they close forever.
Yes. The incredible improbability of us being conscious observers right now makes that short time feel incredibly precious. Urgent, even.
Yeah, urgent.
Absolutely. The source material really pushes this idea. Because we won this impossible lottery, the ancestry lottery, the planetary lottery, we almost have an intellectual duty.
A duty.
Yeah, a duty to use this brief conscious window we have to actually learn about and appreciate the universe, the mechanisms behind it all, rather than, just retreating into easy, unexamined myths or stories.
So the shortness of our time actually makes the pursuit of science more important.
It elevates it potentially into a kind of moral imperative Don't waste this impossibly lucky chance.
Okay, so if we accept that, if we accept we're impossibly lucky just to be here, conscious on this planet, how do we actually maintain that sense of wonder day to day?
That's the challenge, isn't it? We have to constantly fight against what philosophers and scientists call the anesthetic of familiarity.
The anesthetic of familiarity, like a drug that dulls our senses. Exactly. It's that sedative of ordinariness that just settles over everything because we see it every single day. The amazing becomes mundane. So we have to actively force ourselves to see the world in unfamiliar ways, like seeing it for the first time.
Like seeing it as alien.
Precisely. And since, popping off to another star system isn't really an option for most of us,
Unfortunately.
we have to look for the alien right here on Earth. And the sources point straight to the deep ocean, the cephalopods, particularly the octopus and the squid.
Squid? Okay, Martians on Earth.
If there are Martians on Earth, that's them. Think about their skin.
The color changing, right? Camouflage?
Well, yes, but it's so much more than just camouflage or, a mating display. The science suggests it's potentially complex communication. Their skin acts like a gigantic, super high-resolution, high-speed LED billboard.
An LED billboard?
How? It's packed with thousands upon thousands of these tiny little sacs of color called chromatophores. But here's the amazing part. Each tiny sac has its own dedicated miniature muscle controlling it.
Its own muscle.
Its own private muscle. Squeezing the sac open to show the color, relaxing it to hide it instantly. And the nervous system has to coordinate thousands of these across the whole body surface, creating complex, rapidly changing patterns. The processing power required is just astounding.
So it's not just blending in, it's like they're broadcasting complex signals across their skin at high speed. That level of control, it is alien compared to us.
It snaps that anesthetic of familiarity instantly when you grasp what's actually happening there.
Okay, or think about our own bodies. We see ourselves as, one person, a single entity.
Right, but the sources detail this really stunning revelation from biology. Each one of your cells, fundamentally, is like a town of bacteria.
Town of bacteria.
And our whole bodies are like gigantic megalopolises of bacteria.
Okay.
We're descended directly from ancient ancestral bacteria that gave up their freedom maybe 1 billion years ago to form this cooperative whole.
So I'm not just me, I'm a giant walking, talking bacterial collective.
Billions and billions of them working together. That definitely lifts the pall of the ordinary, doesn't it? Realizing you're this vast ancient community.
It really does. Okay, but the biggest leap, the hardest thing for our brains to handle, you mentioned it earlier, it's grasping geological deep time.
Deep time, yeah. Our brains, they evolved for the short term. Seconds, minutes, days, years, maybe a few decades, a lifetime.
Even things like millennia. Ancient Egypt. Homer that feels ancient, gives us that little shiver, that frisson of immense age.
Right. But that's nothing. That's barely a blink in the grand scheme of things.
So how do we visualize it? 4 billion years. It's just a number.
It is. So we need analogies. The sources offer a really detailed one using books. We need a yardstick, let's say. 4 inches, okay, or 10 centimeters if you prefer metric. That thickness of a sturdy book represents 1 millennium, 1,000 years.
Okay, 4 inches is 1,000 years. We stack them up, starting now, flat on the ground.
Right. So to read about Jesus Christ roughly 2 millennia ago, you only look up about 20 centimeters, just above your ankle bone?
Just my ankle. For all of Christian history.
Pretty much. What about Agamemnon? Ancient Babylon. Maybe 3 millennia ago. That only gets you halfway up your shins.
Okay, so all of recorded human history, basically, is a pile of books I could comfortably sit on.
Easily. It's shockingly brief when you scale it like this.
All right, but now we have to go back further, to our earlier ancestors.
Yeah.
What about the taming of fire? When was that?
That's Homo erectus, our ancestors, maybe 500,000 years ago, 500 millennia. So 500 books, each 10 centimeter thick.
Okay, wait. 500 times 10 centimeters, that's 5,000 centimeters, 50 meters.
You need that stack of books to climb to a height, as the source says, somewhat higher than the Statue of Liberty.
Higher than the Statue of Liberty. Just to get back to the taming of fire, we've gone from my shins to the top of the Statue of Liberty.
That's the scale shift, and we're not even close to the beginning. What about Lucy? Our famous Australopithecine ancestor walked upright maybe 3.2 million years ago?
Okay, 3.2 million is 3,200 millennia times 10 centimeters. That's 32,000 centimeters, 320 meters.
That stack now has to climb higher than any skyscraper in Chicago just to reach Lucy. That's the depth of just our human story.
This is already blowing my mind. But we haven't even started on real deep time yet. The dinosaurs, the trilobites.
Exactly. Let's go back to the trilobites. Those cool ancient arthropods crawling around the seafloor 500 million years ago.
500 million years. That's 500,000 millennia times 10 centimeters. Good grief. That's 5 million centimeters.
Yeah.
50,000 meters.
56 kilometers, actually, or about 35 miles high. That stack of books representing time back to the trilobites would reach 35 miles straight up into the sky.
35 miles. You literally can't grasp that scale without some kind of external reference. It's just...
Yeah. It's why the other analogy is helpful, too. To visualize the whole saga of life on Earth, 4 billion years, forget a stack. Think of a bookshelf.
Yeah.
This bookshelf holding all those volumes of time, it wouldn't fit in a library or even a city. It would have to stretch for hundreds of miles. The source suggests from London all the way up to the Scottish borders.
A bookshelf hundreds of miles long, just to hold the history of life.
The raw number, 4,000 million years, it just washes over you. But a bookshelf spanning a country, that sticks. You feel the scale difference.
That scale is, yeah.
Yeah.
Which leads perfectly into the next analogy, which I think is maybe the most visceral one, the arm span.
Ah, yes, the arm span of evolution. So fling your arms out wide as you can. Your left fingertip is the very beginning of life on Earth, about 4 billion years ago. Your right fingertip is today.
Okay, got the image. Left tip is the start, right tip is now.
Right. Now, for the first 3/4 of that entire span, all the way across your chest, past your right shoulder, maybe even to your right bicep, life consists of nothing but simple bacteria, single cells.
3/4 of all time is just bacteria.
Pretty much dominates the timeline.
Yeah.
Complex, multi-celled life, invertebrates, that only really gets going somewhere around your right elbow.
Okay, elbow. What about the famous ones? Dinosaurs.
The dinosaurs. They originate maybe in the middle of your right palm, and they go extinct somewhere around the last knuckle joint of your right index finger.
So their entire reign is just my palm and finger.
Roughly. And now for us, Homo sapiens. All of human history, everything we think of as history, civilization, art, philosophy, technology, all of it
Yeah, but where are we?
is contained entirely within the thickness of one single nail clipping off the edge of your right fingertip.
A nail clipping.
Yeah.
Humbling doesn't even cover it.
I honestly struggle to hold that scale in my mind consistently. It means almost everything we worry about, everything human society is built on, exists in the statistically insignificant sliver of cosmic time.
And understanding that rarity, that sliver of time we occupy, actually helps explain something else, doesn't it? The fossil record.
Ah, yes, the perceived gaps in the fossil record. It's a common sticking point for people resisting evolution. They demand this perfect, continuous series of fossils showing every tiny, gradual change.
Like a movie reel in stone.
Exactly. But the math, the sheer scale of time, and the rarity of fossilization shows that's an utterly impossible demand.
How so?
Okay, let's do another thought experiment from the sources. Imagine every single one of your direct female line ancestors going back 500 million years.
Yeah.
Imagine each one somehow got perfectly fossilized into, say, a 1 centimeter thick pancake of rock.
Right, a stack of ancestor pancakes.
How thick would that stack be if you had one for every single generation?
500 million years is 500 million, let's say roughly 20 years per generation. That's 25 million generations times 1 centimeter, 25 million centimeters.
Wow.
250 kilometers.
The source calculates it as closer to 1,000 kilometers thick, or 600 miles. That resulting rock column would be 10 times thicker than the entire Earth's crust.
600 miles thick, just for my direct female ancestors.
Hypothetically, yes. Now, compare that to the real world. Look at the Grand Canyon. It exposes maybe 1 billion years of history, right? It's about 1 mile deep.
Okay, 1 mile deep.
Even if every single layer in the Grand Canyon was stuffed solid, wall to wall, with perfectly preserved fossils from that period, it only has enough physical space to hold about 1/600th, 1/1600th of those generations.
So the Earth literally doesn't have enough room to store a continuous record.
Not even close. Most potential fossils are destroyed by erosion or subducted back into the mantle or crushed or just never form in the first place. Fossilization is incredibly rare.
So the fact that we find any transitional fossils, any evidence at all,
that's the miracle. That's the remarkable luck. Expecting a perfect, unbroken chain is like expecting every raindrop that ever fell to be preserved. The absence of a perfect record isn't evidence against evolution. It's the expected outcome of geology and probability.
this incredible scale, this deep time, it leads us straight into that classic debate about science itself, the one famously voiced by the poet Keats.
Ah, the cold philosophy argument.
Yeah. Keats wrote that philosophy, And by extension, science will clip an angel's wings, conquer all mysteries by rule and line, empty the haunted air, and gnomed mind unweave a rainbow.
The idea that explaining something destroys its beauty, its poetry.
Right. It reduces it to mere mechanics, but the scientific counterclaim, which our sources really champion, is that the explanation, the solution, often turns out to be far more beautiful, more elegant, more poetically satisfying than the original puzzle ever was.
If you think the rainbow has poetic mystery,
You should try understanding relativity or quantum mechanics. Science, the sources argue, doesn't diminish wonder, it transforms it. It assists the imagination back to the hot birth of time and forward to the eternal cold. It gives us a grander stage for poetry.
Okay, so let's take Keats's prime example, Unweaving the Rainbow. To show how the science enhances the poetry, we first need to understand the basic physics, right? Refraction.
Exactly. So white light from the sun isn't really white. It's a jumbled up, scrambled mixture, as the source says, of different wavelengths of light. We perceive the whole mix as white. And light travels as waves or particles.
Well, it's complicated quantum stuff, but for this, thinking of it as waves works perfectly. Or photons behaving like waves. Each color corresponds to a different wavelength. Red has a longer wavelength, blue-violet has a shorter one.
Got it. And refraction is the bending of light.
Yes. It happens when light passes from one medium to another where its speed changes, like from air into water or air into glass. Crucially, light only travels at its maximum speed, c, in a perfect vacuum.
So when it hits water, it slows down.
It slows down by a factor related to the water's refractive index.
But why does slowing down make it bend? Change angle. I remember you mentioning a great analogy for this.
Ah, yes, Peter Atkins' lifeguard analogy. It's brilliant for illustrating the underlying principle. Imagine you're a lifeguard on a beach and you see someone drowning out in the water.
Okay, gotta save him.
Right. Now, you can run much faster on the sand than you can swim in the water. So, what's the quickest path to reach the drowning person? Do you run straight to the water's edge, directly opposite them, and then swim straight out?
No, probably not. Because swimming is slow. I'd want to spend less time swimming.
Exactly. You intuitively know you should run further along the beach, where you're fast, to lessen the distance you have to swim, where you're slow. You run at an angle along the beach, then cut into the water at a steeper angle.
Right, minimizing the total time it takes, not necessarily the total distance traveled.
Precisely. You choose the path of least time. And light, incredibly, does the exact same thing automatically. When it hits the water at an angle, it bends, refracts to take the path that will get it through the water in the shortest possible time. It acts as if it's calculating the quickest route.
That's Fermat's principle of least time, right? The universe being efficient.
It's considered one of the most elegant and, yes, poetic principles in all of physics, this inherent striving for economy.
Okay, that's beautiful in itself. Now apply it to the rainbow. Why do the colors split apart?
Because water doesn't slow down all colors of light equally. Remember, different colors have different wavelengths. Blue light, with its shorter wavelength, interacts more strongly with the water molecules. It gets tangled up more effectively.
So blue light is a slower swimmer in water than red light.
Exactly. Blue light slows down more significantly than red light does when it enters the water. And because it slows down more, it bends more sharply. It refracts at a greater angle than red light.
Ah, so the act of entering the water drop naturally separates the colors because they bend by different amounts.
Precisely. That's the first split. Then, inside the raindrop, the light rays travel to the back surface, reflect off it like a mirror, travel back to the front surface, and then exit the drop, refracting again as they go back into the air.
And bending again as they exit, separating the colors even more.
Yep. So you get this beam of separated colors emerging from each raindrop.
Okay, but why the curve? Why is a rainbow always an arc?
The geometry is beautiful.
Yeah.
You, the observer, are the center of the rainbow circle. Your eye is the focal point. Think about it. For you to see red light, it has to exit the raindrops at a very specific angle relative to the incoming sunlight, and your eye, about 42 degrees. For you to see blue light, it has to exit at a slightly different, smaller angle, about 40 degrees.
So only certain raindrops at the right positions in the sky can send the right color to my eye.
Exactly. All the raindrops that are positioned correctly to send red light to your specific eye form a circle or an arc in the sky. All the raindrops positioned correctly to send blue light to your eye form a slightly smaller inner arc.
So the red is always on the outside, the blue-violet on the inside.
Always. And because it's centered on your line of sight, everyone sees their own unique rainbow. The person standing next to you sees a slightly different rainbow formed by different raindrops.
That's incredible. So the rainbow isn't a fixed thing out there. It's a personal phenomena, an interaction between sunlight, water droplets, and my eye.
Perfectly put. The knowledge of the physics, the differential slowing of light, Fermat's principle, the geometry centered on the observer, it doesn't unweave the rainbow. It adds layers of awe and elegance Keats never dreamed of.
Wordsworth's heart might indeed leap up even higher knowing that. Okay, let's zoom out. From raindrops to stars. Unweaving starlight.
Right. When astronomers pass starlight through a prism or spectrograph, they don't just see a continuous rainbow. The spectrum is crossed by hundreds of very fine, sharp, dark lines.
Fraunhofer lines.
Named after Joseph von Fraunhofer, who cataloged them. These are absorption lines. Atoms in the star's cooler outer atmosphere absorb very specific wavelengths of light coming from the hotter interior.
And each element absorbs its own unique set of wavelengths.
Exactly. Each element, like hydrogen, helium, iron, calcium, has a unique spectral fingerprint or barcode of absorption lines. It's incredibly precise.
Which completely refutes that famous claim by the philosopher Auguste Comte back in 1835.
Oh, Comte. Yes. He confidently declared that while we might learn things like stars' distances or movements, we would never, fundamentally, could never know their chemical composition. He saw it as an absolute limit on human knowledge.
And yet, within decades, spectroscopy was doing exactly that. Today, it's routine.
Completely routine. Spectroscopy is our stellar catalog. By analyzing the light, especially those barcodes, we can tell a star's chemical makeup, its temperature, its pressure, its size, even how fast it's rotating or if it's moving towards or away from us.
We can classify them. Like our sun is a G2V yellow dwarf.
Class G2V yellow dwarf star. Yep, it's all in the light's barcode.
And again, this knowledge, it just elevates the poetry, doesn't it? These aren't just abstract points of light. They're nuclear furnaces.
Actively smashing hydrogen atoms together to make helium, releasing incredible energy. And later in their lives, the bigger stars forge heavier elements through fusion, the carbon, the oxygen, the iron.
The medium-sized atoms of which we were eventually made.
Exactly. We are literally made of stardust, the ashes of long-dead stars. Identified by the same chemical barcodes we see across the cosmos, that connection, revealed by science, is pure cosmic grandeur.
And these barcodes also let us measure how stars are moving, right? Using the Doppler shift.
Yes, the same principle as the changing pitch of an ambulance siren.
Right, the E sound.
Yeah.
Higher pitch coming towards you, lower pitch going away.
Light does the same, but with color or wavelength. If a star or galaxy is moving towards us, its light waves get compressed slightly, shifting the whole pattern of spectral lines towards the blue end of the spectrum. A blue shift.
And if it's moving away from us?
The light waves get stretched out, the whole barcode pattern shifts towards the red end of the spectrum. A red shift.
And when Edwin Hubble started measuring the shifts of distant galaxies in the 1920s,
Yeah.
what did he find?
He found something astonishing. Almost all distant galaxies are redshifted. And the further away they are, the more redshifted they are, meaning the faster they're moving away from us.
The universe is expanding. Everything is flying apart from everything else.
That's Hubble's law. And if you run the movie backwards, if everything is flying apart now, it means in the past, everything must have been closer together.
Until you get back to a single point.
A point of unimaginable density and temperature. The Big Bang, the beginning of space and time as we know it, somewhere between 10 and 20 billion years ago.
And here, science hits a wall almost. The concept of an event, the beginning of time itself, that literally has no before. Our brains just weren't built for that.
It pushes the limits of logic and causality as we experience them. Maybe only poetic awe or, dare I say, mathematical abstraction can really grapple with that primordial moment.
But that same Doppler shift technology has another amazing application today. Finding planets around other stars. Exoplanets.
Absolutely. We usually can't see the planets directly. They're too small, too faint, too close to their bright star.
So how do we know they're there?
We watch the star very closely. If a star has a planet orbiting it, the planet's gravity doesn't just pull on the planet. The planet's gravity also pulls back on the star, making the star wobble slightly as the planet goes around. A tiny wobble.
Tiny, but detectable. As the star wobbles slightly towards us in its little gravitational dance, its light gets minutely blue shifted. As it wobbles slightly away, its light gets minutely red shifted.
So we look for that regular, rhythmic, back and forth shift in the star's spectral barcode.
Exactly. That tiny repeating Doppler wobble is the signature of an unseen planet tugging on its star. It's incredible detective work, teasing out these tiny signals from light years away.
And it's the main way we're discovering thousands of other worlds out there, opening up that profound question of whether we're alone. The science itself is just beautiful.
Okay, so we've seen how science reveals this deep, authentic wonder, but that very human need for wonder, for poetry, it's constantly being, well, hijacked, isn't it?
It absolutely is, by forces that prefer easy answers, appealing narratives, over the often harder work of finding actual facts. This brings us squarely to the need for critical thinking, for robust skepticism.
We have to defend the real poetic science from what the sources call bad poetic science.
Right. Bad poetic science is all about rhetoric that takes a superficial resemblance, a casual analogy, and inflates it into some huge, cloudy symbol of a high romance.
Like assuming that because two things look alike, they must be causally connected.
Exactly. It's the foundation of a lot of magical thinking, what Sir James Frazer famously called imitative magic in his massive work, The Golden Bough. He spent decades documenting rituals based purely on these kinds of surface analogies.
Give us an example.
Well, the classic one is the belief that powdered rhinoceros horn is an aphrodisiac. Why? Because the horn vaguely resembles an erect penis. There's no actual physiological reason. It's pure resemblance equals effect.
Or rainmakers trying to make it rain by sprinkling water.
Yes, like trying to conjure a homeopathic dose of rain by imitating it on a small scale, sprinkling water from twigs, mimicking thunder with drums. It's elaborate effort based entirely on analogy, not any understanding of meteorology.
Some of these rituals Fraser documented were incredibly complex, weren't they?
Oh, astonishingly so. He described the Dieri people of Central Australia. Their rain-making wizards would literally be bled, letting the blood drip onto the ground to symbolize falling rain.
Oh.
Then they'd violently butt their heads through a specially built hut wall to symbolize piercing the clouds. They even kept, grimly, a stockpile of boys' foreskins, believing they had some homeopathic power to produce moisture.
Wow. The sheer effort involved.
The effort, the pain, the expense, all poured into systems based on incredibly weak analogical logic. You have to feel a kind of non-condescending amazement at the human ingenuity misapplied there.
And this tendency, this hijack of wonder, it's absolutely rampant today, just in different forms. Think about astrology. It still outsells astronomy books by a huge margin.
It does. And the sources pull no punches, calling the 12 signs of the zodiac facile dumpins.
Facile dumpins, I like that.
It's an insult, really, to the sheer complexity and richness of individual human personality to just shove everyone into one of 12 crude categories.
And the science shows it just doesn't work, right?
Consistently. Psychologists have tested it again and again. Astrology's predictive power, its reliability coefficient, is usually around 0.1. That's barely distinguishable from pure random chance, like throwing dice.
So why is it so popular?
Cognitive ease, mostly. Confirmation bias. It gives people simple boxes to put themselves and others into. It feels meaningful, even if it isn't statistically valid.
We also need to talk about how this anti-rational worldview gets reinforced, sometimes insidiously, through fiction. The sources mention shows like The X-Files.
Right. Now, obviously, it's fiction, it's entertainment, but the pattern is what matters. Week after week, the show systematically presents a world where the rational, scientific explanation is usually wrong or incomplete.
And the supernatural, the paranormal, the conspiracy theory routinely turns out to be the correct explanation. Mulder is usually right. Scully is usually wrong until the end.
And that relentless pattern, even in fiction, can have a corrosive effect. The source makes a powerful comparison. Imagine a fictional crime drama where every single week, the black suspect always turned out to be guilty.
Oof.
Yeah, that would be rightly condemned.
Even if the creators said it's only fiction, because the pattern reinforces a harmful, unjust stereotype. The argument is that constantly reinforcing the idea that science is clueless and the supernatural holds the answers does a similar, albeit perhaps more subtle, kind of damage to critical thinking.
So how do we fight back against this? Against bad analogies, cognitive biases, fictional reinforcement? We need tools.
We need sharp statistical thinking. We need to understand the coincidence trap. And the sources introduce a great acronym for this. PETWAC.
PETWAC. What does that stand for?
A population of events that would have appeared coincidental. Basically, how many opportunities were there for something coincidental seeming to happen?
Okay, give us the classic example. The psychic on TV stopping watches.
Right. The scenario. A supposed psychic goes on live TV, claims they will use their cosmic energy to stop watches in the audience. They do some dramatic intoning.
It's like immediately the phone lines light up. People call in amazed. My watch stopped right when they said it would. The audience is stunned. Proof. Okay, let's apply PETWAC. First, estimate the base rate. How often does any given watch stop anyway? Battery dies, gets dropped, mechanism fails, maybe once a year on average.
Sounds reasonable, once a year.
Okay. How many 5-minute intervals are there in a year?
It's roughly 100,000. So the probability of your specific watch stopping in that specific 5-minute window chosen by the psychic is tiny. 1 in 100,000.
Very low odds for me personally.
What's the population? How many people are watching the show? Let's say it's a hit show, 10 million viewers.
Okay.
And let's be conservative, say only half of them are wearing watches at that moment. So that's 5 million watches in the potential pool.
Right. The population is 5 million watches.
Now, multiply the low individual probability, 1 in 100,000, by the huge population, 5 million. What do you get?
5 million divided by 100,000, that's 50.
You'd expect about 50 watches in that audience to stop in that specific 5-minute window purely by random chance. The source calculation gets about 25 per minute, so 125 in 5 minutes, either way. That's more than enough to generate a flood of amazed phone calls. It looks like a miracle, but it's just mundane statistics operating on a large population.
Exactly. Petwack reveals the hidden opportunities for coincidence.
And the antidote to this kind of magical thinking is often just finding the real, usually simpler explanation, like Richard Feynman's story.
Feynman's grandfather clock story, yes. It was this beloved old clock that supposedly stopped dead at the exact moment its owner died. Very sentimental, sounds meaningful.
Oh, the real reason.
Much simpler. The owner, in their final hours, had apparently tilted the clock slightly to see the face better in the dim light. That tiny tilt was just enough to gently stop the highly sensitive pendulum mechanism.
No psychic connection needed, just physics.
And Feynman's point was that the true mechanical explanation affirms the elegance and beauty of an orderly universe, which is ultimately far more satisfying, more profound than a cheap, spooky coincidence.
So where does this susceptibility to coincidence and magical thinking come from? Why are we so easily fooled?
It likely stems from childhood. The sources talk about childhood credulity. Kids have to be gullible initially. They're like information caterpillars, needing to absorb vital information from trusted adults' parents, elders for sheer survival.
Like, don't touch the fire, it burns. Or, watch out for crocodiles by the river.
Exactly. You can't afford to learn those things by trial and error. So evolution favors brains that start out with a high degree of trust and belief in what authorities say. It's a survival mechanism.
But that same mechanism means if you tell a kid something untrue, like about the Easter Bunny or Santa Claus,
they'll believe that with equal conviction because the believe authority program is running. The problem arises if that default credulity isn't gradually replaced by critical thinking as we mature.
if we don't grow out of it.
That childhood virtue becomes the adult vice of unhealthy and reprehensible gullibility. It leaves people as sitting targets for quacks, conspiracy theorists, cult leaders, astrologers, anyone peddling easy answers based on weak evidence.
And it's often combined with the opposite problem later, right? The sources call it a devastating combination.
Yes. Extreme early gullibility followed by equally obstinate subsequent unshakability. Once a belief gets locked in during that credulous phase, it can be incredibly difficult to dislodge later, even with overwhelming evidence.
The Jesuits supposedly knew this. Give me the child for his first 7 years, and I'll give you the man. Early programming is powerful.
Incredibly powerful, which is why fostering critical thinking skills early is so vital.
So is there a kind of ultimate test we can apply when faced with extraordinary claims, like claims of miracles?
There is a fantastic logical razor proposed by the philosopher David Hume back in the 18th century. It's a benchmark for evaluating miracle claims.
Okay, what is Hume's test?
Hume argued that, quote, no testimony is sufficient to establish a miracle, unless the testimony be of such a kind that its falsehood would be more miraculous than the fact which it endeavors to establish.
Okay, say that again slowly. The testimony's falsehood would have to be more miraculous than the miracle itself.
Exactly. You have to weigh the probabilities. Which is more likely? That the miracle actually happened exactly as described, or that the witnesses are mistaken, lying, hallucinating, or otherwise deceived. Whichever explanation requires the smaller miracle, the less improbable event, is the more rational one to accept.
That's a really high bar for accepting a miracle. Let's apply it. What about that famous miracle of Our Lady of Fatima in Portugal, 1917?
The miracle of the sun, yes. Huge crowds gathered, reportedly 70,000 people expecting a sign, and according to many witnesses, the sun appeared to detach itself from the sky. dance erratically, maybe plunge towards the earth before resuming its normal place.
70,000 witnesses. That sounds like strong testimony.
It does on the surface. But let's apply Hume's razor. We have two basic explanations. Option A. 70,000 people in a state of high religious expectation, perhaps influenced by strange atmospheric conditions or mass suggestion, experienced a localized mass hallucination or misreported events, or perhaps there was some level of collusion or exaggeration after the fact.
Okay, that's option A. The testimony is false in some way.
Option B. The sun. A gigantic thermonuclear furnace holding the entire solar system together with its gravity actually detached itself from its position, performed physically impossible maneuvers visible only in one small part of Portugal, and then returned to its exact spot, all without disrupting the orbits of the planets or being noticed by astronomers anywhere else on Earth.
Right. Option B requires the laws of physics to be fundamentally broken, and also requires a simultaneous illusion of non-movement to be staged for billions of other people around the world.
So which is more miraculous? That 70,000 people were mistaken or misled in some way? Or that the fundamental structure of the solar system was temporarily dismantled and reassembled?
Clearly, the mass hallucination or misreporting, while maybe unusual, is vastly less miraculous, vastly more probable than the sun actually moving.
Hume's logic leads inexorably to rejecting the miracle claim. Science doesn't diminish the event's historical or sociological interest, but it offers a far more parsimonious explanation. It replaces a localized magic trick with the consistent, universal, and arguably far more wondrous spectacle of physics. #tag outro.
Wow. So we have covered a lot of ground today. We journeyed from the almost unbelievable luck of your specific conception,
Right back to the cannonball and the sneezing peasant.
through the mind-bending scales of deep time, measured in 35-mile-high book stacks and arm spans where humanity is just a nail clipping.
To the beautiful, elegant physics unweaving rainbows and starlight, revealing not cold mechanics, but deeper poetry.
And finally, the absolute necessity of skepticism and critical thinking to protect that real scientific wonder from the distortions of pseudoscience and faulty logic. Science, it seems, doesn't kill the poetry. It is the poetry.
It provides the most magnificent, awe-inspiring material for it. And perhaps to end, we can loop back to the instrument that allows us to perceive all this wonder, the human brain itself.
Ah, yes, the brain, which experienced, as the sources say, perhaps the fastest advance recorded for any complex organ in the last million years or so.
This incredible explosion in size and capability, likely driven by some kind of self-feeding spiral between hardware, brain structure, and software, cognitive abilities. But the big question remains, what was the critical software key? What specific cognitive innovation really kicked off that explosive growth?
The sources suggest a few really compelling possibilities, big ideas we're still trying to unravel. Was it language?
Yeah.
Specifically, maybe its unique power for recursion embedding ideas within ideas infinitely, or just its open-ended nature, allowing us to name and discuss literally anything.
That's a strong contender. Or perhaps a different idea, map reading. Think about our ancestors as master trackers, reading animal footprints, broken twigs, essentially reading a story, a graph of movement over time, laid out on the landscape. Did the ability to generalize that skill to maybe scratch a scaled-down representation of the landscape in the dust, the first map, did that trigger the cognitive leap? Did it unlock abstract spatial reasoning, planning, foresight in a whole new way?
That's a fascinating idea. A map as the key. Or the third candidate.
Ballistic movements. Throwing things accurately, a stone, a spear. It seems simple, but it requires incredibly complex, precisely timed parallel processing in the brain to calculate trajectory, release point, muscle coordination.
More complex than it looks.
Much more. Could those sophisticated timing circuits, evolved for throwing, have provided the neural foundation, the hardware that was then co-opted or repurposed for other complex sequenced tasks, like making tools, creating music, maybe even structuring language itself?
Language, maps, or throwing. 3 possible keys that unlocks the human mind.
These are the kinds of huge, unwoven questions still driving science. They show that the more we learn, the more we unravel, the stranger, the more magnificent, and the more wondrous the universe and our place in it actually becomes.
An event with no before. A paradise planet against all odds. A brain that exploded in complexity. That's the real poetic stuff right there. So, we have to ask you listening, what do you think? Which of those software innovations, language, map reading, throwing, feels like the most plausible trigger for the human brain's great leap forward? Or is it something else entirely?
We'd love to hear your thoughts.
Let us know in the comments below. And please, if you enjoyed this deep dive into scientific wonder, do us a huge favor. Hit that like button, subscribe if you haven't already, and maybe share this with other curious minds you know. Your support really does keep us going. We'll be back soon with more beautiful facts.